So first of
Okay.
all, give you introduction about yourself, and then we will start.
Okay. So my name is Sudhir Uswal. I'm a fourth year undergrad from Bachchan Jani campus. I'm currently pursuing mechanical engineering, and I'm a kind of a sporty person. I play all kind of sports. And about my experiences, I have done one internship back in back in May, June, July 2021 in Switch organization. I was lead of machine learning team. Our major work was to build a web extension. They were build a fake news detection, build a fake news detection system, and embed it with the web extension part. Apart from that, I also did a project under Gina. I built a beat recommender system, which is used to recommend that recommend same type of beats like the search system we use in Spotify and YouTube, something like that, and on a very low code base. So we can give input to it and we can get similar sounds of like that. These were two projects I did, and apart from that, I am interested in majorly I'm interested in data engineering and machine learning part, and my both of my projects were related to machine learning only. That's about my project.
So now this is a technical round. So I am
Okay.
going to ask two medium level questions. Be
Okay.
comprised of 45 minutes. Okay.
Okay.
So open
Can.
the Google Doc.
Okay.
So this is the first question. Go through this. If you
Okay.
want, I will explain.
Sure. Each version is return true. Only if you can choose X greater than equals to 2 so that it is possible to split the entire deck into one of the each group has exactly X cards. Okay. All the cards in the group have the same integer. Okay. So like according to my I have read the question and according to my understanding, can I open a whiteboard so that I can tell you what I'm
Yes,
exactly
sure.
thinking? Do we have any constraints on the deck? Like the first thing.
Like in starting, don't assume the constraint. Just whatever solution you give.
Okay. Okay. Let me tell you what I'm thinking. Like, what's my understanding about the question? So, like, let's say we've been given some decks, and each card will have some integer written on it. Okay. Let's say we are given some vector of that. Assuming we have given the input as a vector, and let's say we have given a vector of size, let's say n. Okay. And what we have to do, we have to like just partition into different groups, and each okay we have to partition into some different groups. Each group should have same number. Each group should have the same size should be one constant, and one group can consist of only one type of integer, right? Am I right about this?
What you see?
So like we need to divide the whole vector. Let's say we
Yes,
have to divide into different groups. Each group should have the same size, which
yes, yes,
will fulfill this condition,
yes,
and each group can only contain one type of integer, right?
yes, yes.
Okay.
Like every group have same number, and each group have
Okay.
all groups have same size.
Okay. Okay. Like Well, first of all, okay. The first approach I'm able to think right now is to use a unordered map. What I'll do is I'll traverse over it, and I will store each of the I will store each of the different elements into it as a key, and their frequency is the other part of the map. After doing one traversal, what I'll do is I'll again traverse over the map, and I will check the frequency of each occurring element. All the occurring elements should have the same number in it. That would be my first approach.
I think you are not going in the right direction. The mapping kind of technique is strict, okay? But let's take an example and let's
Yeah,
take an example. Go on the whiteboard.
yeah.
Let's take an example 2 2 2 2 2 2 4 times. Okay, four
Okay,
times, four
okay,
times,
okay.
and 4 6 times.
4 6 times.
Yes,
Okay, I still have a black. I still have a paper with me. So
yeah, and 4 6
two and
times. Let me write on the
four.
Google Docs.
Yeah.
So is like I am writing on the Google Docs. Is it visible to you or not?
Yeah, yeah, yeah. Yes, yes.
Okay, so
I'm able
2
to see
4
it.
times and 4
Yeah.
6 times. Okay, 4 6 times. So now what is the so if I am asking like can you divide this deck into equal partition? What is your answer? True or false?
False.
No, it's true because you can divide two into like you can divide this first two into the first group of a group of a
Okay.
two number. Okay, then you again
Okay.
divide this two into the equal number, and you in the same way you have divide all those four into two, and this constraint is feasible right now. Like you have divided all the numbers into equal
Yeah, yeah.
groups, and all groups have same number.
I got it. We can put another condition in that. I guess with that condition, the unordered hash map way would work. So in this case, uh, can I tell you? Can I go with that approach first again? Like we need to again modify that approach.
Okay, okay.
So if I traverse over this deck of array, and then do I have an edit access?
Yeah.
Do I have an
Yes, yes,
edit
yes,
access?
yes.
Okay, it's
It
not
is not
giving me that.
coming.
Yeah.
I've already given.
Like what I'm thinking is, we can take a GCD of greatest common divisor of all the frequency, all the occurring frequencies. If that GCD is greater than one, then it's possible. If that GCD is equals to one, then it's not possible.
So can you explain again? I'm like giving the link access.
Yeah.
Yeah. Right now I think you can type some.
No, not able to.
So wait 1 minute. It's not. So what is your email ID?
Oh, acha. Okay. Postal with it at the acha. I changed that ID. That's how you might be a problem. It's let me type on the.
Okay.
I joined with a different ID. That's a, that it might be a problem because of that.
I have sent the link. Can you check your mail? Yeah, I've sent mail. I will increase your time 5 minutes more.
Thank you. Yeah,
Right.
now I'm able to write. So
So what is
if
your
I
mail?
yeah, so again if I go with the unordered map approach,
Yes.
so what if I traverse over this? What would I get? And let's I'm just trying to make a hash map of it. So two as a key, I'll get four as a frequency, and four as a key, I'll get six as a frequency, right?
Yes.
What I'll do, I'll take a GCD of two, four, and six, greatest common divisor,
Okay.
and the GCD of four and six will come out as two. GCD of 4 and 6 will be equals to 2. And like I'll put a constraint like this: if the GCD is greater than 1, then it's possible. If GCD is not greater than 1, then it's not possible.
Okay. Go with the code.
Go with it. Should I code in here also? Here only?
Yes. Yes. Just write the function, not full-fledged code.
Okay. Okay. Let's just say I have a vector in tech. Okay. What I'll do is I'll do a okay one word map, and name the unknown map as u1. Then I'll go for int I equals to 0, y to be less than duck dot size duck plus plus I plus plus u1 of I plus plus. So after this for loop, frequency of all the different occurring integers will be there. After this, what I'll do is to it would be equals to u1 dot begin, and put int gcd as a underscore gcd. I'm using the STL function of gcd,
So just
and
use function here. Like make another function for GCD.
what I'll do, I'll just make a boolean function. I'll just name it as check if possible, and I'll just put a unordered map in comma int u1. So this function will check about whether there is a possible partition I can do it or not. And what I'll do it just to u1 dot again, and I'll do a int gcd equals to it dot second first. And should I also type the gcd function?
No.
No. Okay, so while it is not equals to u1 dot end, what I do, gcd equals to GCD of GCD comma dot and do it plus plus the follow and so after this while loop, GCD will contain the greatest common divisors of all the frequencies. After this, I can just make a return function. Return if GCD is greater than 1, then it will return true, otherwise it will return false.
So can you explain the last line why GCD greater than 1 is true, false?
Can you repeat again?
So can you
Like
explain why if
why this condition?
GCD value is greater than 1, then why it is true and why it is false
Yeah.
if it is less
So
than
why is it?
1?
Why I have put this condition, right? GCD greater than equals to greater than one,
Yes,
right?
yes.
Okay. So um, what will GCD will do is like if I take this example as a way to explain it. So in this one, as a hash map, what I'll get is against one I'll get 3 as a frequency. Against two again I'll get a 3 as a frequency, and against three I'll get a frequency of 2. Okay. Now if I take GCD of 3 of 3 and 3, which will give me again 3, and then I take a GCD of 3 and 2, this will give a frequency of 1. So basically what GCD will give is the biggest group of which like all the elements or all the numbers can be divided into different groups, right? So if let's say in this example which you gave me, in which two had a frequency of 4 and four four had a frequency of 6.
6.
Yeah, we can divide 4 into like one of size 1. We can divide like if an element has a frequency of 4, then we can divide it into 4 buckets of each of size 1, right? And again we can divide this the element which is occurring 6 times, we can divide it into a bucket of one size into 6 different buckets of size 1. So there are like different number of possible combinations in which we can divide all of them. And like GCD will give me the biggest bucket size in which all the frequency element can be divided. Basically, this condition x is greater than equals to 2.
Okay.
This is like this will be guaranteed by the GCD part.
Yeah, yeah, I understand. Like these both constraint fulfilled by that condition.
Yeah,
Okay, so now can you tell me the time complexity and the space complexity?
yeah. So this for loop will take O1. Okay, this for loop will take O1, and this is again there's again a possible condition like possible, and we are using another hash map. I guess time complexity would be O1, and space complexity will also be O1.
Yes, overall order of n.
Time complexity would be an order of n, and space complexity would also be for order of n only. Like for space, we are using a hash map. That's why space complexity is O1, and time complexity we are taking a for loop here, and we are also taking a loop over hash map here. Yeah, that's why space complexity goes around O1.
Move to the bottom part, you will get the second question. Go through it, and if you have any problem, then ask.
Do every element, right? Left and right are non-empty part. Left has smallest possible size. Return the length of it. Like, can you explain me this test case? Because like there could be a possible condition in which left is only equals to zero and right has three, five, and eight and six.
No, it is always guaranteed that there is one valid answer for this test case. Like,
Like
okay,
I'm not able to understand this test case. So can you explain this one?
okay. So like 50386. So if you carefully see that we have divided the partition in such a way that all the right part is greater than left side. Like 86 is greater than 503. So we have to find in the maximum right side. So where we can go into the right side up to like all the right side will be always be greater than left side. So we have to find
Okay.
we can you can also give the answer like 50. If you divide
Why?
from 50 there, then the partition is not possible. Like in the right side 3 is not greater than the left side.
No, still like I'm thinking like let's say if it partition into left has only zero and right has eight, six, five, and three.
Okay,
Then what's like which condition is getting broken?
can you write the example?
Yeah. So left has zero and right has three, five, six, and eight.
So if both are combined, then you have to divide in such a way, but that's it. You have to divide 0 in the left part and 3, 5, 6, 8 in the right side. Like all the right side number is greater than 0 in the left from the
Yeah.
left part.
So like all the right parts are greater than zero only, right? Like why this condition? Like why this partition is not valid? I'm not able to understand that part.
Why this partition is not valid?
Yeah.
This partition is valid.
Why, so like answer should be one, right?
Yes,
Because
yes.
left has smallest possible size.
Yes, here answer will be 1. You can also think in the way that you can write the answer 1, 2, 3. Like if you move all are in sorted order, right?
Yeah, that's
So if you are
that's
thinking in a
that's what
position like
I was
you
thinking.
can
So
write 1, 2, 3, 4 any answer, right? But you have to think in a smallest possible way. Like what is the smallest answer? You can partition the left side and the right side. Did
okay,
you get my point or not?
I guess okay. I guess I can't move this. Like I have to put a constant here, right? Here only, I guess. So like I have to divide. I can't move this element's position, right? And if
Yes, you
this
can't move the position element.
okay, they have been written two continuous surveys. Okay, I got confused in the question. Okay,
For the test case you have written, the answer will be 1.
yeah, but this is not valid. Like with this nums, this is not valid. I got it.
Yeah.
Okay. First approach I'm able to think is a very brute force approach. So what I'll do is I'll put a two nested for loops, and I'll with every j I'll partition it. I'll again go backwards, find which element is the biggest, and I'll go again traverse in the forward direction, find which element is the shortest, and then I'll check whether this condition whether the condition is possible or not. Did you get my approach?
Yeah. So can you
So
explain
two,
means any other test
yeah.
case? Your brute force
Okay.
approach.
Yeah, yeah. So let's take nums as something like um, just put a random word. So I'll first divide, like, I try to divide by keeping three in the left part, and okay, let's in the first condition, first partitioning. Let's say I'll check so left would be equals to 3, and right will have all the left out parts. Well, after this, I'll check what is the biggest number in the left part, which is 3 right now, and I'll check the lowest number in the right hand part, which is 3 right now, and then I'll check whether the left hand bigger element is lesser than the right hand lower element, which is false in this case. So like this partitioning won't work. Then I'll go with the second partitioning. It would contain left as 3 and 67. Right would be as I can just copy these things. And in this again, I'll try to find the left max, which in this case would be 67, and right min, which would be equals to 3. And again and again the condition will not be able to be satisfied, so the
Why
condition
not?
will be false.
In the same way, you will traverse for all the loop like
Yeah,
that.
I'll partition at every point. Time complexity of this approach would be O n square, and space complexity would be equals to O1.
Okay.
Yeah, this would be my approach.
So can you optimize this?
Yeah, I'm trying to think about that only. Okay, this is also easy. What I'll do, I can just copy this thing. It's really easier to explain. We have this example anyway. So okay. So, like there are two key important parts in it. There's a left max and a right pin. Okay. So what I'll do is I'll first make two vectors, and for each of the vector at a particular index, I can like I will store what is the minimum element for the. Okay. Let me show it to you. It's much easier. So what
Okay.
I'll do is I'll make two vectors. Let me name them as
So can
left
you
max.
up like up?
Okay, sorry. Two vectors left max and right min. Now left max will store left max vector will store like, at a particular index what is the maximum element including that index and all the indexes before that. Am I clear about this? So and the right one will store the same thing, all the elements in the right hand side, including itself, which is the minimum element among all of them.
Will that index?
Yeah, including that index. Will store all the including that index, including that index. Uh, so will the maximum element in the left hand side, including that index, and right we will store the minimum element. in the right hand part. These two vectors will store these two things. After this, we can again traverse, compare, and the time complexity would be reduced to time complexity will be linear and space complexity will be linear too.
So can you optimize more?
So right now its time complexity is O(n) and
So
space
first,
complexity.
what you will do, you will try run this approach, and once I'm satisfied, you have to optimize this also.
Okay, I can take it. So I should dry run. I can give example of the above example
Just
only.
take 508. That's it.
Okay, 5, 0,
8.
and so left max would be like a vector which will contain 5, comma 5, comma 8, and right min would contain 8, 0, and 0. Yeah, like in this thing, we will get these things, right? Like we will get left max as this vector and right min as this vector. Now what I'll do, I'll again go with the like I'll again loop over the left max, and I'll start comparing. It would be like whether the left maximum is lesser than the right minimum. So like at this index, so I will be partitioning it like as a 5 and 0 comma 8. Clearly in this one it is false right now. Then
Yes.
there will be another partitioning 5, 0, and 8. In this it would be true. And I guess we can't have the empty elements.
Yes,
Like
yes.
I can't have a vector like, so I'm not talking. I will not be like, we will not consider that case also. So in this case, I will be comparing this, like for the first index, I will be comparing this and this index, because like in this right minimum, this particular index is also included. So when I'm going for the first element, I will be comparing it with the next index of the right minimum.
Okay.
So 5 and 0 will be compared. Now 5 is greater than 0, that's why it will be false. In the second point, 5 is greater than 8, and it will return true. Like 5 is lesser than 8, and then that's why it will return true.
Basically, you are taking left max and right max and you're comparing, and you are finding that which element and the writer extent is like greater. Suppose in comparing 5 and 0, so here 0 is smaller than 5, so it can't be partitioned. So you will try
Yeah.
another. Okay.
Yeah. So like in the first partitioning in this one, so the left max is telling me that in the left hand side of this index, including this index, what is the maximum element. So in this
Okay.
case, it is 5 right now. And in the right hand part of the next index, it is representing what is the minimum element, including all the right hand elements.
Yeah.
So it would be like O of O8. Yeah.
Yeah. So can you
And,
more optimize this like in order of space complexity?
like, okay. Um, we can go with this single, like we don't need to keep a track of these two vectors also. We can do it with the simple one, like constant space also. We can just take left max as a variable, right min as a variable. Left max will traverse in the forward direction, right min will traverse in the backward direction. At the same time, there would be like telling at the same at the index, it will be telling that at this index, left max will be representing all the what is the maximum element, including this element in the left hand side, and right minimum would be telling all the elements excluding this index, what is the minimum index? Yeah, it could be done in a constant space too.
So just write the code. So wait, I will give you the link. There you have to write the
Yeah,
code.
yeah.
What's the question? Second question. Just wait for 1 minute.
Yeah.
Okay, I've attached the question just in the chat. Just zoom in on the code. Yeah,
Is it visible to you?
yes, yes.
Okay. Mm, should I go with the last approach?
Yes, yes.
Yeah. So what I'll do, I'll just keep int left maximum, and I'll initialize it with int minimum. I'll put a right minimum. To keep track of right minimum.
So just wait. You start.
In this case, this the thing I was thinking about that getting like keeping only a constant space for right minimum. I guess it is not possible to do that. I guess.
So
So
can you
like
give me just 5 seconds? I will come back.
can I code the vector approach first? Because uh, like I'm not pretty sure that I can do this thing in O1 space,
Hello?
the right
Sorry.
min part.
I was on mute. I don't know about that.
Okay.
So what are
Like
you?
actually, I'm not able to think that I'm not pretty sure that right min part can be coded like can be done in with constant space because like minimum we are going to traverse in this way. I don't think that it is possible with that approach.
Okay, so let's try whatever you know, like
Yeah,
with space.
I'll go with the second time space O(n) and space complexity also with O(n). Do that first. I can and left and straight. Again, common numbers dot end. I just copied the nums and nums into left and right like this.
Yeah.
Now I'll do forward. Right, right plus plus. The left of right equals to minimum of left of 5 comma left of I minus 1. Like in this one we have to keep a maximum actually. So 5 0. Okay, minimum. Yeah.
12 more minutes left.
And for I click to drop side. I have to keep a track of right minimum, right? So okay, I write r minus 2. So I drop size minus 2. I to get them equals to 0. And I minus I equals to minimum of I to I comma RIGHT I plus 1. This will like minimum for these plots, right? So 508. Okay. Then I can be like or print void less than. Try run on this one. What is one? But written the right size.
Try with all example.
Yeah, I guess this approach should work. So like this is the with time complexity equals to O(n) and space complexity would be equals to O(n) of 2. This will be the approach left and right, then calculating the max, calculating the left max and right minimum, and then comparing left I and right I plus 1. Now see try to space complexity. Like, should I try any other test case with this one?
Just you can try out any other test case.
Should I
Think.
try any other test case with this one?
Let me try. 7419.
You're not audible.
7419.
7419.
19.
We can do it, right? Yeah.
Yes.
Now, if we try to again optimize the space complexity of this one,
Can you click on submit?
one and one is a possible solution, not a solution. Like, how can we, like, even if we try to do it, how can we do that? Because less than or equals to, sorry. Here, 1 comma 1 on array r. Yeah, it works.
6 more minutes left. You can still think of optimization.
Yeah, I'm thinking of that only. If we try to optimize it, we need to absolute maximum. Try a step. Like the possible solution is into a space, a constant space complexity, right?
But
Like the possible optimization will lead to a solution of constant space, right?
yes, yes. Not in the terms of time complexity, but yeah, you
Okay.
can optimize in terms of space complexity.
How we can do that? Constant states. Back to like, somehow if I can do this thing in like in a linear part, like with the same traversal of this one, I can do that. But like this thing can be merged with this part, but I'm not able to merge this the above part with this one. How can I do that? So part outside of it. Like I'm able to think of an approach which will lead to like a constant space complexity, but it will again increase the time complexity to O(n) square.
So now you are done, or you will want to try.
Like, can you give me a hint or like
You can think in the terms of not in the right minimum. You can just maintain left maximum and right maximum, and you can think in that direction. Like for example, 508. You have to
hmm,
think like first you have to start with the both maximum. Right maximum and left maximum is 5. Now you have to find that right maximum number for which the left part, all the left all the left max is smaller than the right max. So in this way you can partition both the number. So you have to find the right max correctly.
Like I'm thinking of a like binary search something.
Mm, not in the terms of
Sure.
binary search. You can go in a linear search way. Like for example 508, if you are
Yeah.
comparing like
Mm.
508, so if you are comparing 5 with 0, so here it is not possible.
Yeah.
So you move to this number. So
Zero.
first assume that left max is 5 and right max is 5. Both are current. Now
Okay.
you will turn, just iterate the loop for from I here to here. Again you will check the right maximum. Right maximum is again my 5 because 0 is still smaller than 5. Okay. So if you are thinking in a way like 5 is still greater than 0, so here the partition is not possible because in the right side 0 is smaller than 5.
Yeah. Okay.
So you
But
will,
like, won't it lead to a n squared time complexity because we will be looping outside. Then again, we will checking in whether this possibility whether this index is possible or not. So it will lead to an n squared time complexity, right?
no, no, but here you are taking two variable, right? 508, and you are just comparing this
Hmm.
those both value. Not for every value. You are just updating once you find the correct right maximum. Like for here in this example 508, 8 is the correct right maximum, and you compare with the left maximum that is greater. Okay. So in this case, suppose you take 5086,
Okay.
506, 5048, 48.
All right. Wait. 5048.
5048. Okay. So now here left maximum is you can still take 5, yeah, 5048. If you compare 5 with 0 and 5 with 4, yeah, it is a good example. So for this, suppose you are comparing two elements like left maximum and right maximum, both are
Like
mine on 5.
right now, okay. So left maximum is right now five,
Yeah,
and
right
right
maximum is also on 5.
maximum is also equals to five. Okay.
Now you are comparing from the first index.
Yeah.
So you check here like 0 is greater than left max or not. So you can also use that left max is smaller than this number, this arrow of index of I. So if it is greater, you can't do divide. You can't divide. Okay.
Okay. I'm thinking of what. Let's say like if I put something like two in here after
Yes.
four, and something like 10 here,
Yes.
9 here. So
So first, I think I have to stop recording. And do you want your feedback? Like time is over right now. Then we will discuss on
yeah,
this.
yeah, sure. Like
Okay.
what are the possible areas I can improve on that?
So from my side, if I am an interviewer, I will select you because you just like conclude all those things from brute force to brute better approach. You explained all those things very rightly.
Okay.
You have to write the syntax correctly, like not use ij every time.
In this first question, right?
In the second question, I guess in the first question you used it, so write the correct syntax.
This is the correct syntax, right?
Correct syntax means like not the naming fashion. Syntax is
Okay.
correct, naming fashion,
Like
proper name.
I have to put a reasonable naming.
Yeah, yeah, reasonable. Not the
Okay.
correct
Okay.
syntax. Its syntax is
Yeah. So
correct, but
like it
proper
doesn't
naming.
mean anything.
Yeah.
Should. Okay. Okay. Got
Okay.
it.
In both the example, apart from that,
Okay. Yeah.
everything
In
is
this
fine
one.
because you started from brute force to brute better, and you are just discussing. In first example, you are just approaching in wrong direction. By giving one hint, you pick up the right thing, and you
Mm.
give the right solution at the right time. So that's my feedback. Do you have
Okay.
anything want to say?
No, it was pretty good. About this question,